live from GTC, it's CoreWeave. I'm your host, Lisa Martin. Welcome to day 2 of an incredibly high energy AI Super Bowl. We are here in the booth, our second story. You can see a little bit of the glimpse. I call it the Times Square vibe behind us. Guys, the energy at GTC 2026 is off the charts. I'm so excited for this next conversation. I've got Philip Kiely here, the wearer of many hats, the head of AI education at Baseten, also book author. We're going to be talking about that. Philip, thanks so much for joining. It's great to have you.
Hey, thank you so much for having me. This is an amazing vantage point to see everything going on at GTC.
Isn't it? Yeah. So, one of the things that we want to talk about today is inference.
Yes.
This is the engine that powers every AI application in production, and today it's all about being in production. And when you and I were talking before, you said, training models gets a lot of attention, and it has for a long time, but the real challenge for businesses comes after, and that's running those models reliably, efficiently, and at scale. Talk about inference engineering as a discipline and why it's so important to adapt this now.
Yeah, I mean, people used to think inference is easy, but it's actually not. If you heard Jensen's keynote yesterday, I feel like half of it was about inference, which was really validating to hear. The challenge is that doing a little bit of inference is actually pretty easy. If I just want to take a model and run it on my laptop or run it on a single H100 just to play with it and see if it's good, not that hard. That's a solved problem. The challenging piece is doing that at scale, doing inference for hundreds of thousands or millions of users, and then doing inference fast, doing it with the lowest possible latencies, the highest throughput, doing all of that cost effectively, and then doing it reliably, because all of these systems are very new, very research oriented, and very fragile. And when you combine that technical reality with product expectations of 4 or 5 nines of uptime, those two things don't always mesh so well.
So you just launched this inference engineering book in what, February 2026?
Yeah, 3 weeks ago I published it.
3 weeks ago.
Yeah.
So talk about why the timing now is so impactful.
I was blown away by the reception of this book. I've done 16,000 copies already.
Congratulations.
Thank you. Yeah, which has been, mind-blowing. Like, if you think about, the New York Times bestseller list, like, to get included in that, you generally have to do 5,000 or 10,000 copies. So this is like...
You blew it out of the water. Yeah,
this is an enormous distribution. And I want to take a little bit of credit for that, but a lot of it was about the market and the moment. There's so many people today who understand that inference is where we're going, but what we were missing in this industry was a single primer that could, take any engineer from any background. We see inference engineers from everywhere. People who were SREs become inference engineers, product engineers, full stack, everyone's learning inference. And I've had the fortunate position of working in this industry for 4 years. And so I was able to take everything I learned in 4 years, put it in one place, and deliver it to the market right when the timing was hot.
Amazing, amazing. So you in the book, you cover everything from CUDA to Kubernetes. What was the single hardest concept for engineers to internalize when they're building an inference infrastructure? And because you talked about speed, everything is at speed.
Yeah, I think the hardest concept is, it's a bit nuanced. If you look at any optimization, let's take KV cache reuse as an example. In simple terms is, if you have a request to a model, you get a response back. During that process, there's a valuable artifact called the KV cache that gets created. Okay. And then if you send the same request or a very similar request to that model, you can reuse that KV cache to make that second request faster. Now,
and more accurate?
Just faster. All I do is faster.
Okay.
And so the importance of something like that is the way you build your system actually affects whether or not that works. So with KV cache reuse, it's a prefix that gets reused. So that's the first bit of a prompt. So if I ask what's the weather in New York City, and then I ask what's the weather in San Francisco, the what's the weather piece gets reused. But if I change my prompt slightly and I say San Francisco weather today, New York weather today, nothing gets reused.
Okay.
So And you can see a similar thing in speculative decoding with needing a speculation algorithm that actually reflects your real world data. You can see the same thing with quantization with your calibration set. With every single one of these techniques, there's some aspect of your real world use case that affects how well these systems perform. And it's difficult for someone who has maybe a background in very deterministic systems or is approaching this from more of an academic angle to really think from a use case first angle and build their systems in that direction.
How do you, from a cultural perspective, how do you advise, and maybe it's even part of the book, which I am happy to be matching with today, folks
yes, great St. Patrick's Day outfit.
Yeah! I did my best. But how do you advise folks from a cultural perspective to adapt that mentality? Because speed, competitive advantage, pressure, it's there. So how do you, with folks that were SREs moving into inference engineering, as you said, what's the cultural advice in terms of adjusting in real time, but also at speed?
I think it's developing a very incremental approach to rolling out into production. I mean, when you write a book, for example, you got to get everything perfect and then you ship. But with software, especially with an inference system, you can make it work. Just get the model running. Then make it a little faster.
MVP? Yeah.
Make it faster, stabilize it, iron out the bugs. Especially when you're doing a lot of like day zero launches, you have to accept that a system's not going to be perfect the moment you publish it. But if you kind of know what to do on the fast follows, then you can kind of learn from the way the system's being used in the real world, rather than trying to optimize everything in the dark and then bring it to market.
It's too late anyway.
Exactly.
Right? So in terms of, we talk a lot about production, like so much piloting going on the last couple of years, it's all now about getting things into production. You talked about the real world, and that's where the application I think is most impactful, but what actually goes on putting these models from training into production?
So when you train a model, what do you get at the end? Like the final result is a bunch of big matrices. It's a bunch of safe tensors files. They're literally just files of numbers sitting there in a hard drive. So how do you actually get these numbers and make sense of them? The first step, obviously, you got to get compute. You got to get some GPUs. You got to take the weights and load them onto the GPU. Now that's the first challenge, right? Because if you have a model like Kimmie K2.5 thinking. I've been in this industry a long time. I remember back in the day when I started working in inference, and I was working with like 300 million, 500 million parameter models. Whisper came out, it's 1 billion parameters. Back then we could just bake the weights into the image because it was a few megabytes or a gigabyte. Now if you take a model like Kimmie K2.5 thinking, 1 trillion parameters, and you take that in, say, FP4, so each parameter is half a byte, you've got 500 gigabytes of weights. You've got to get 500 gigabytes of weights onto your GPU before you can even start thinking about inference. That takes, if you think about, a naive system where it's maybe a gigabyte a second, it's 500 seconds. That's quick maths. That's like 10 minutes just to get the weights onto the GPU. Yeah. So there's that piece, like how do you optimize that? How do you get your streaming your weights on to 10 gigabytes a second, 100, like you get it much, much faster. And then once the weights are there, you actually have to do something with them because all you've done is move your static file from one place to another place. So now it's like, how do you actually run that? That's where you bring in an inference engine. You have to configure that inference engine to be able to have the appropriate specifications for the exact workload that you're trying to do. You have to take that and put it against an endpoint. And then once you've done that, you have to do it over and over again to scale it up and down dynamically in response to traffic. Yeah, I mean, every single piece of this has to be fast. Your cold start has to be fast. The actual inference engine has to be fast. The scaling up and down has to be fast. The network latency matters. Every single piece of it matters. And that's what's so hard about it. It's dozens of different technologies. Yeah. It's multiple different engineering disciplines all happening together in millisecond, multi-millisecond SLA envelopes in terms of latency.
So in your experience, what surprises most teams about that? Because there's a tremendous amount of complexity that you just described. Seconds, milliseconds, nanoseconds matter. What gets teams caught off guard, and how do you help them resolve those challenges?
I think one of the things is because this space is so new, there is a lot of exciting research going on, and people will like read a paper or see a new open source tool and be like, all right, we're done. Like, we're just gonna take this and put it on the GPU and we're gonna go in production and everything's gonna just work. But with the complexity of these systems and the fact that a lot of the novel things in this industry are very much from a research type of perspective, research code is not famous for its robustness. And so you have to do a lot to kind of harden these techniques and standardize them and get them to a point where you can actually rely on them rather than just experimenting with them.
And you find that they're like mentally, culturally adaptable to that?
Oh yeah, 100%.
Right?
It's always a surprise when you expect something to work out of the box and then weeks later you're still debugging. So having experience with that process, and we've been doing a lot of original research ourselves, which has been very exciting, and having the opportunity to deliver that research in production. We've done stuff like MTP. It's a new speculative decoding technique that we've been using a lot, and yeah, it's always a challenge to take something, even something that's very rigorously proven out, and actually deliver it across different models, different systems, different traffic patterns, all that kind of stuff.
But so much opportunity.
Oh,
so
yeah.
I know, like CoreWeave, Baseten works with a lot of different customers, World Labs, Notion, Open Evidence. What are their inference challenges? Where do you see like a common denominator, and where are they divergent?
Yeah, I mean, it's very easy to think about where they're divergent. You listed, 3 fantastic companies that we have the privilege to work with. And if you think about, someone like an Open Evidence, their whole thing is the speed and the reliability. Doctors are relying on this technology to serve their patients. So uptime and all that stuff is critical. But it's critical everywhere. Notion uptime is critical, World Labs is critical. The main commonality that all of these companies have is the importance that inference plays in their business. They're all AI native. They all have built very sophisticated AI tools into the core paths of their user. And so if their inference is down, if their inference is slow, their product is down, their user churns, all that kind of stuff. So it's up to us to make sure that doesn't happen.
Yep. They depend on you, they rely on you.
Exactly, and that's a privilege. Like to work on the most mission critical use cases is a privilege and a responsibility, and one we take very, very seriously.
That's a perfect mentality. So here we're at GTC, day 2. You guys recently, Basteen, announced day zero support for NVIDIA's Nemotron 3. What does day zero support actually mean for developers and enterprises that have to adopt new models really, really quickly?
Yeah. It's been really fantastic to work with the Nemotron team, and they've provided us a lot of great support and insight throughout the process. I think that the importance of day zero support is kind of knowing that the bugs are worked out. Obviously, you can never get anything and everything before the entire world comes in and starts playing with it. In fact, I actually experienced that myself when someone found a typo in my book.
Oh no!
But for the most part, you're expecting a sort of polished experience with day zero support. I think the importance of adopting new models is that there is actually a lot of testing that goes into it. From a technical feasibility perspective, sure, you can just pull out an endpoint, stick in a different one, but LLM-based systems are very complicated, and if you do that, your system is going to start behaving differently. So there's a whole world of evaluation and prompting and product development to get a new model ready, and being able to start that process immediately upon a model launching is critical for keeping up in this industry.
In terms of keeping up, how does GPU choice affect inference outcomes in the wild in practice?
I think about it as like right sizing. I don't have any cars, but if I had a Ferrari, I'm not necessarily driving it to the grocery store, and if I had a Camry, I'm not necessarily driving it on the racetrack.
Yeah.
So there's a lot of work that goes into right sizing, like putting latency insensitive embedding workloads on cheap L4s, or using multi-instance GPU to split up H100s to more efficiently run voice models, that kind of stuff. But honestly, the teams who are working on that stuff, that's very critical for them. But when I'm out talking in public, all anyone wants to hear about is the latest and greatest GPUs. And using Blackwell systems, we've optimized our entire inference stack for Blackwell. We run on a lot of B200 GPUs. and using stuff like NVFP4, using Blackwell adapted kernels and inference engines. That's definitely the priority for especially like the large language model inference that everyone's so excited about.
When you're talking with customers though, what's the real constraint? Is it raw compute? Is it memory? What is that?
Yeah, really the constraint is everything. But the main thing is that it's not really about like, can you get me this many flops? Can you get me this much, memory bandwidth? It's, will my model be fast? Will it be affordable? Will it be reliable?
Yes.
Will it scale to reach my audience? That's really what people care about, and the hardware specs and stuff I find fascinating, but oftentimes those are just an implementation detail on the way to the outcome.
And it's all about the outcomes. So we're in CoreWeave's booth.
Yes.
CoreWeave and Baseten work together.
Yes, very happily.
Talk to me a little bit about what the partnership is enabling your customers to do in terms of running these large-scale inference workloads far more effectively.
Yeah, I mean, the big thing is capacity and flexibility. If you launch a new AI tool, you might get millions and millions of views on Twitter the day you launch it and have tons of users coming and checking it out. And handling that kind of spike in a system like this is very difficult. And so that's one of the places where our partnership is really, really critical, is not just supporting people on the day-to-day, but supporting these companies on their most important days, their critical launches, when big customers onboard and spike usage. And through the sort of capacity and flexibility that we get from CoreWeave, we're able to do that.
You look out into the future, and it's, I would say 3 years, but I'm not going to say 1 because things are moving so fast. What does the inference engineer role look like a year from now?
Yeah, I mean, the first thing is I think a year from now there are going to be a lot more inference engineers. When I started at Baseten, I didn't even really know what inference engineering was. It took me a couple years to even think of myself as one, but maybe back then, that was before ChatGPT came out, there were a couple hundred engineers in the world who really knew how to run like large-scale transformer model deployments. Now there are thousands and thousands, and in a couple years, I think there could be hundreds of thousands of engineers. And this is, this might not sound like a high number, but I'm already accounting for the acceleration and the leverage that AI tools are going to give these engineers. Even with that, I think there are going to be hundreds of thousands of really critical jobs in inference of people, running these systems, configuring these systems, deciding what to build. And I'm really excited about that because as the stack gets more complicated, bigger, and more important, there's just going to be more and more exciting work for us to do.
So last question, for our audience who might be thinking about getting into inference engineering, because you've described it so beautifully, what are some of the key skills they should be working on now, since the opportunities that you described for roles is huge? Yeah,
I mean, there's a lot you can do. You can do local inference, you can run models on your computer with stuff like Llama, Llama CPP, you can get into maybe like Comfy UI and some of the image generation stuff, but I mean, it's never been easier to get your hands on a little bit. It's very hard to get your hands on a lot of GPU compute.
Yeah.
But it's never been easier to get your hands on just a little bit of compute to play around with. And so there's a lot of really like novel and interesting problems left to solve everywhere in the stack.
Yeah.
There's lots of low-hanging fruit in, say, like kernel optimization in the video generation space. There's thousands of open tickets and requests on VLLM and SGLang and all that kind of stuff. So there's a ton of great open source work to do, and yeah, there's just, the demand is growing so fast in this space and outpacing the supply that if you get in now and literally just do like anything, like any remotely feasible technical project, in 6 or 12 months, like you're going to be so far ahead of everyone who hasn't been playing in here. Like I've seen people come into this space and months later they're experts. So yeah, it's just growing so fast that there's not really a lot of gatekeeping, and there's not a lot of prior art that you need to master. I mean, the book is 250 pages and 42 of them are appendices. Like it's not that much to master before you start contributing at the frontier of this space.
I love that. So like the time to adding value is short.
Exactly.
That's
yeah,
huge.
maybe
it's inspiring for
instead
people.
of time to first token, we should talk about TTAV, time to added value.
There you go.
But yeah, I mean, we've had a bunch of people like join Baseten and immediately have a huge impact in this space. So if you're a smart, motivated engineer, like this is the place to be.
I love it. So for those smart, motivated engineers, where can they find Inference Engineering?
So the book is available for free on baseten.com/Inference Engineering. We have a free PDF, free EPUB. I'm working on getting as many physical copies as I can printed and shipped everywhere. So we have a wait list up for that. I'm hoping to allow people to self-serve eventually, but I'm going to be at all the conferences. I'm here at GTC, going to be at HumanX, at Google Cloud Next, AI Engineer World's Fair, and a bunch of others, and all over San Francisco, like handing out these books. So definitely like come find me, grab a book, and welcome to the early days of Inference.
Welcome to the early days of Inference. I think that's a mic drop moment. Philip Kiely, thank you so much for joining us.
Hey, thank you so much for having me.
Explaining what Inference Engineering is. I'm going to disagree with your shirt. He is not artificially intelligent, guys. This is legit. We're going to put in the show notes where you can find for free a copy of Inference Engineering on the Baseten website. You can follow Philip around, follow him on social media. Thank you so much for sharing the discipline, what it takes, but also the tremendous opportunities that are there for the taking. We appreciate it.
Thank you so much for having me.
My pleasure. For Philip Kiely, I'm Lisa Martin, live from GTC with CoreWeave. Thanks for watching, guys. We'll see you on the next episode.